Okay, so we're also going to talk about logarithmic functions, and we'll go through this a lot quicker. So let's recall some basic facts about logarithm functions. If we've got y equals log base b of x, remember when x equals 1, then y is equal to log base b of 1, which is 0. All right? That's one of our special values of logarithms. So this special point 1, 0 is on the graph. When x equals b, y is equal to log base b of b, which is equal to 1. That's another special value of a logarithm. So this special point b1 is on the graph. The function is increasing. It goes up as you go from left to right. And the function has a vertical asymptote x equals 0, which is the y-axis. As an example, graph this log base 2 of x on Desmos. Also graph the special points 1, 0 and b1. All right, so b is the base of a logarithm, so it's 2. So for this function, that's b1 is 2, 1. And graph the vertical asymptote x equals 0 to see how all of these things work together. All right, so I'll give you a moment to do that. Okay, so we need one piece of terminology, and that is for a logarithmic function, whatever we're taking the logarithm of is called the argument. So for example, this function, we're taking a logarithm of x, so the argument is x. With this complicated function, we're taking a logarithm of 2x plus 1, so the argument is 2x plus 1. Okay, so any transformations of the logarithmic functions will preserve the vertical asymptote, and so the only thing that's affected by is a horizontal shift that'll move that vertical asymptote. The function approaches the vertical asymptote in one direction and bends away from it towards positive or negative infinity in the other. So for these facts, we can use them to sketch any transformation of a logarithmic function by finding the vertical asymptote. This happens where the argument is equal to 0, right? Because x equals 0, which is the argument, is the vertical asymptote. And then we can find those two special points on the graph. Those will happen for the easy argument values 1 and b. Okay, so let's see how to put all this to work. We've got this function that's a transformation of the log base 4 of x function. And we'll do these three things. We'll find the vertical asymptote, find the two special points, and sketch. Okay, so to find the vertical asymptote, we're going to set the argument equal to 0. All right, and so the argument was x plus 3, because here's what we're taking the log of. That's the argument, x plus 3. And when we solve that, we get x equals negative 3. So this line, x equals negative 3, should be our vertical asymptote. Next, we'll find our special points. So one of those happens where the argument is equal to 1. And so let's find the x value where the argument is 1. So we set argument equal to 1. Argument was x plus 3. We solve by subtracting 3 from both sides. We get x equals negative 2. And then we'll substitute that x equals negative 2 into the function. Okay, here's our function. Replace the x with negative 2. Inside the parentheses here, negative 2 plus 3 is 1. And we know that a log, any logarithm base anything of 1 is equal to 0. Okay, so this log base 4 of 1 is 0. Negative 0 is, of course, 0. 0 plus 1 is 1. So when x equals negative 2, y is 1, and that gives us one special point, negative 2, 1. To find the other special point, we want the argument to equal b, the base of the logarithm, and the base of the logarithm here is 4. Okay, so first we'll set the argument equal to 4. The argument is x plus 3, so x plus 3 equals 4. Subtract 3 from both sides, we get x equals 1. Now we'll substitute that x value into the function. All right, so we'll replace this x with 1. And then inside the parentheses, we got 1 plus 3, which is 4. No surprise, we wanted the argument to equal 4, and now it does. And whenever the base and the argument are the same, then the logarithm is just equal to 1. So this log base 4 of 4 is 1. So we have negative 1 plus 1, which simplifies to 0. So x is 1, y is 0. That gives us another special point, 1 comma 0. Okay, so here's the solution to this problem. The vertical asymptote we said was x equals negative 3. The two special points are negative 2, 1, and 1, 0. And to sketch the graph, we'll start off by putting the asymptote and the two special points on. Okay, x is negative 3 here, negative 2, 1 here, and 1, 0 here. Of course, we have to decide which direction this function is going to approach the asymptote from. It could either approach it up here or down here. And we see from these points that we're further away from the asymptote, getting closer. And so that means that the function must come in like this, right? So it comes in like this, goes through this point, goes through this point, and continues going to the right and down, as we see when we put in the function. Okay, so there's how you graph a logarithm function. Okay, I hope you enjoyed this video and look forward to seeing you in class on Tuesday.